Alright, this is the schedule. So today I will cover what is PLM, and then we will have two presentations by Youngki and Soonjo about softwares for TOM project. Right. And I guess Youngki will also explain about the TOM project itself. It is already passed to you by email from myself. So it can be covered quickly, but there can be some questions. All right, and then also we have a Umshik who is guiding the question hours. I don't know whether we can do a long time. All right, so this is my slide for them. So many portion is already covered, so I'll be quickly move on. So you can stop me, otherwise I can go faster. So it starts from outsourcing or extended enterprise concept. So why we need a PLM and what is PLM and web services, and also step is started as a translation between CAD system. Nowadays, PLM is covered by step 2. This is diagram showing what is the main component of manufacturing. We talked about PLM and ERP and MES last time about automotive industry. There is a product development division where all the designers and engineers are working for. And also there is a factory floors where the real production is working. And there is a management board which covers manpower, resource, and financing, and also procurement. So those are three big departments also inside the company. So many people are saying that small company is pushed by big companies by contract. Inside in Korea we have a 갑질관계, right? So big company has big power to push down small companies. But in technological point view, I can say that small company or big companies depending on small companies for quality and cost. Right? Because of the competition, worldwide competition, global competition, we have because of that oversupply, overcapacity of smartphone or car or ships, there is more than capacity than market size. So that's why we have a high competition among country and among company. Sometimes it is only phrase coming from 10 years ago. Only top 5 global automakers will survive in the near future. We see that the market share of the top big companies, also smartphone too, right? Samsung, Apple, and Huawei, some of the Chinese, they have a most share of market. That's why we have outsourcing is increasing. And because of the outsourcing, the concept of extended enterprise is coming, and mass customization is a reason why this is competition. And to produce such a meet the requirement of mass customization, there is a mixed stream production inside the company. This idea is coming from Toyota. Also, just in time is Toyota coming. And modular design and assembly ideas. So this one is already shown to you many times. The Ruji factory in 100 years ago. But now the factory is changed to here. So you see this is Ruji. There is a level of sightseeing. You can walk around this assembly plant. This is assembly line, right? There is some people working on each station, okay, along the conveyor belt. And then we can walk around because you see this TV is for tourists, not for workers, right? This one is for tourists. So tourist level is higher here. So you can walk around in this, second floor to see the assembly line. So one portion of the rouge factory, this one is a current, not current, say several years ago. So that there are still some plant. I cannot see some plants somewhere here or somewhere here. The real plant, modern plant. But the others are used for the museum. And this is parking lot, something. So outsourcing the production line is used as an independent company. Spin-off companies. All production cost of product goes to part suppliers because of the outsourcing is increasing. Sometimes it is 100% outsourcing. Right? The Nike, or Apple, they are doing 100% outsourcing of production. Not all cost, probably not all cost, but production cost. Length of the assembly line inside the main company is shortened and shortened every day. So when right, so it's better to stay here. There's a constraint. All right. So when I visit the Samsung Electronics Suwon factory, the factory housing is now empty. No manufacturing inside Suwon factory of Samsung Electronics now. So they are using that housing as a storage or research. So there are high-rise buildings inside the Samsung factory now. All people are working for R&D there. So designing and checking quality control. So that's why no assembly line inside the Suwon factory. Instead, there is a traffic jam for delivery of components, outsourced components. So EMS is Electronics Manufacturing Service, is outsourcing of electronics. They separate out spin-off of mold plant of Samsung Electronics as a separate spin-off company. In Japan, also Electron started with the 2 production line of Sony in 15 years ago, become a big company of EMS. We call this is extended enterprise. Supply chain is important for them because of the outsourcing and OEM. And now the Electron has 60 plants over the world, including China and Taiwan. Supply relationship management, there is a new other. So what is extended enterprise? They should include suppliers, part suppliers and customers into the management scope, comparing to the rouge factory of 100 years ago. At that time, the management boundary is inside the rouge factory because all of them, most of the production is continuous processed inside the factory. Right? Now, most of the parts are outsourced. So you should control the suppliers together. Otherwise, the quality, scheduling has a problem. Right? Component is coming, so that you can do only assembly here. Right? But one of them is missing, delayed, then the assembly line is stopped. So you should control the schedule of the outside suppliers. Also quality. One of them has a problem of quality, then the whole product has a problem. So scope of quality control and management is over the conventional boundary of company. You can think about the rouge factory, the boundary is expanded, so that is extended. Area of interest is shifted from inside integration rather than outside integration or collaboration. So in Hyundai Kia factory e-manufacturing yesterday, yes, we talk about these ones and also some of the CRM and SCM. Now we should see the market survey and operation maintenance, after service engineering, and spare part for AS. And there is a long lead item. Long lead item is it takes a long time to purchase the part. Say, such as an engine. It takes a long time to develop a new engine. So it takes years. So you should have a time, and space-wise, the scope is increased. Mixed stream production, I already said that different cars are coming along the one conveyor belt inside the factory. Right? It can be a Sonata Coupe, Sonata Sedans, or hybrid SUV are coming along the conveyor belt. So mixture of a product is coming along the product line, assembly line. Comparing to T1 car Ford Rouge factory, at that time it was same car, right? Same specification, same parts, and now it's all mixture. Then how can you control the delivery of spare parts coming from outside? But car is coming in different cars. Also, the exporting market is one car is same car, Sonata. It should be go to China. The next one is go to Brazil. Another one is go Europe. So that the specification is different. Regulation is different. Air conditioning, right? Automatic or manual, all different. Automatic transmission, air conditioning for say Iran or Egypt is hot, because hot there, you need to have a high-powered air conditioning there, comparing to Europe. Audio system, airbag, navigation. So part supply, just in time. Just in time means the delivery is done when it is needed. Just in time. Right? So quality and schedule is complicated. Comparing to old times. Modern times is old famous film of Chaplin. In 100 years ago, there is doing only same work. Right? Same work. Because the part is same, car is same, no changes. Right? So there is a modern time. Something like a mechanical. Right? People is working. But now is different, totally different. Just in time, part suppliers should deliver the exact amount of the exact time, delivery time. So there is a pallet. May I see this pallet in here? Right. This looks like a pallet, stacking of pallets here. Right. This is a part that should be assembled, and this person should pick up one part from here and assemble to this car, and this car, and this car, right? Car is different. You see that color is different. Also, specification is different. Say this is a manual car, this is automatic. Audio system is 100 watt or 50 watt. Air condition is different. Then the delivery of the parts is delivered from the other company, outsourcing company. That should be stacked up differently, right? In correct order, correct specification. Otherwise, you can put another component to another car. So it's more complicated. So now you should check with the barcode. So this car and this part should be matched. So you should check with barcode. Okay? Otherwise, there can be mixed match. And there is a pallet, and Kanban system is coming from Toyota. That is something similar to barcode, but there is a memo stick with some name and numbers and specification and date and something like that. So these are all similar things. Kanban, RFID, and barcode is very similar. It is used for pallet identification of car and corresponding part. And if you use just in time, You don't need to have a big inventory. Right? All part is delivered at the correct time. Right? You don't need to have inventory. But the management and controlling is very complicated. So assembly of wrong part in the mixed stream production can be happen if you have a mismatch. Modular design, the modules, say air conditioning module. Air conditioning module is some, we can, where is the air conditioning? This is air conditioning, right? Here is air conditioning. That is a set. There is a one, what is a 실외기? 실외기 is a one module outside of the building for the air conditioning. This one is inside the building module. So heat pump is in the somewhere outside, so that warm heat is going outside, cool air is going here, right? So there is a two portions of air conditioning system. The same as a car. So we call this whole set as a module, and that is for the Hyundai company. Many of them is manufactured by Halla Visteon company. In Halla Visteon is nearby Shintanjin area. There is a big company there. So that part supplier for Mobis is for Hyundai, and Delphi was for GM, and Visteon for Ford. It's a big company also. So we call, say, decrease of international warehousing production, but more dependency on module suppliers. Okay. And PLM, there has been some PLM conferences, International Conference on Product Lifecycle Management. In 2005, it was in Lyon, and oh, there is a homepage of that Lyon, 2005. Right? So now it's 10 years ago. We have a 2008 or 9 in Seoul, so conference there. And design change. This is related to product life cycle. Concept design, basic design, detail design, and construction and manufacturing and testing, and then mass production. Sometimes it's a prototype build and mass production here, and then delivery somewhere. But you see that change or number of design changes. Number of design changes is higher around this prototype manufacturing build or test area. Build. Design changes because they find problems there. Right? But the cost of change, the cost of design change is rapidly increased. So that it's better to make design changes more in the earlier stage of the product development rather than later stage of development by using some simulation or theory or your experience or artificial intelligence somehow. So we call this as a front loading. Front loading means you just change to this curve as a more change in front part and rather smaller in later part. Right? So that is the idea of. So service engineering, we need to have a scientific approach to after service. Say you think about safety of a nuclear power plant after 20 years of operation or 50 years of operation. But the level of safety should be higher than before. 20 years ago, when it started, the level of safety requirement was in this level, but as times go on, safety requirement is higher. So you need to have a higher level of, increasing level of safety requirement. And also we already see that profit share of GM was shifting from production toward the after sales market. So you should have a financing or leasing and telematics. the web services for technology to provide PLM now. It is the outline of what is web services. You see that it's similar to your app, the Apple app, your smartphone app. So service provider and that register your service or app in the internet or web. Then people use request or search app functionality on the web store. Right? So the idea coming from this web services. And this is the component technology, XML, SOAP, WSDL, DDI, more technologies. And originally the middleware was started, say, 20 years ago, and web services started around 2000 to 10 years ago, and app store is coming 5 years ago, right? But same idea is flowing. This is a web complement, a traditional middleware platform, something as COBA or DCOM is coming from Microsoft. By providing a uniform and readily accessible interface and access glue over services that are more efficiently implemented. So if you think about app, anybody around the world can develop app, right? And register into a shop, app store. And anybody around the world can buy and use that app. So how can you do that? You need some standard way of developing, registering, search and download and use. Right? So we need such a technology. International activity for PLM, as it is for STEP, but this is a product data exchange workshop between NASA, you know already NASA, but ESA is for European Space Agency. Corresponding organization of NASA in EU is ESA. And OMG PLM services. OMG is a consortium. There is a well-known Mexico project there. PDX, product data exchange of INEMI, is a manufacturing, electronics manufacturing initiative. You see that EMS is there. And ESA is another organization. Is a software and application for interoperability. And visualization format is 3D, X3D, or JT Open is. Or PDF, 3D PDF is also well known. It is some step application examples of long-term data archiving, long-term product design data, approved by some aviation organization under the type certificate should be retained, retrievable, and usable for the life cycle of the certificate. Say 50 years for the airplane. Design data. Right? Design data should be available for more than 50 years. But you should think about 3 technology life cycle. Product itself, the airplane itself has 50 years more, or nuclear power plant, but storage of data, design data, USB. Can you use USB after 50 years? Same device. Your USB can be opened in 50 years later. Or what kind of software you use? Apple OS, Microsoft can be used after 50 years, because nuclear power plant should be operating at 50 years. So that kind of thing, we need to have some consideration and standard. This chart shows about the step usage in space development. But there are so many APs, AP, UML, AP, PDM, PLM, lifecycle management, inspection AP, another AP, step AP. So this is complication, but this is all mechanical and electromechanical. right? Boeing and some companies there, Boeing. And Eurofighter is from EU. They are developing, or competition with Boeing, right? They are also doing similar PDM data exchange. BAC, British Aerospace Engineering, or Airbus. The partners of that BA or Eurofighter, they are developing Germany, Italy, Spain, and UK, right? So they should export and import or exchange data, but they use different PDM system or PLM system, so exchange is required. Also between electro and mechanical system. This is electronic CAD system, is mechanical CAD system. They use different AP system. So how can you data exchange between circuit assembly and the hardware, mechanical part and electronical part? They need both of them for product. All right. Questions? No? Then we can move on to which one is first? Soonjo or Youngki? Maybe Youngki. You can show the Tom project slide and then yours. Right? 네. 어제 밤에 그런 거. 아, 그건 내가 고쳤다, 그지? 고친 버전으로 하는 게 좋겠다. 고친 버전으로 먼저 하고, 아니, 그 설명을 김영기 씨가 했어요? 네. 만든 사람이 한 건 했지만. 네. 여자 폰트. Your PDF.
Hi, I'm Youngki Kim. I temporary TA to introduce the Tom project. And the aim of the Tom project is development of translator between FreeCAD and Transcript. After this explain, I will explain the FreeCAD and Soonjo explain the Transcript.
Because he did the same project here, this class. That's why he picked up.
And the background of this Tom project, the problem is in real world, the collaborative design among the different geographical locations, actually USA and Korea or other areas. And time waste is time waste due to design changes from the sending and receiving each department. So we should reduce the wastage of time. And in the design process, the different departments use the different different software. So we should transfer the different format. So we to solve this problem, we will have this Tom project. So to solve this problem, develop a translator. Specifically, we focus on the CAD system. So to provide an economical way to exchange CAD data. And another thing is the translator should adopt the macroparametrics approach. This is, I explained briefly. The macroparametrics approach is the methodology, the exchange of model data between CAD systems using a macro file. the macro file is the macro file includes modeling command of commercial CAD system. So as you can see, the CAD system alpha make the macro file alpha, and then we use the preprocessor. We can transfer to exchange to CAD data to Transcript, and then we can check the temporary model in Transcript, and then we can use the post-processor, and we can make the macro file beta. This is for the CAD system beta, and then the different thing of the neutral file format, such as step, IGES. The macro parametrics approach can modify the parameters in models. So as you can see, we can change in this area. We did the chamfer operation. This is the basic theory of the macro parametrics approach. And I briefly explain the FreeCAD. The FreeCAD is the open source CAD system. The first release is 2002, and the last version is in this year, May. About the FreeCAD, I will explain another presentation, so I will skip. So the goal of this term project is that you should make the translator between the FreeCAD and Transcript. So preprocessor is the FreeCAD to Transcript, and post-processor is Transcript to FreeCAD. So we made two parts, pre and post. So the target model is this model in K1 model. So development environment is in Transcript you should use C++, at least C10 or higher, and then Transcript provide the C++ based APIs, so you can use some APIs. And FreeCAD is based on the Python. Do you know the Python? Yeah. So FreeCAD also provide the Python-based macroscript file, macroscript and APIs, so you can use this. That's all. Any question?
There are question session, discussion session, separate. So you can continue.
아니요, 이거를 하다 보면 제 쪽으로 와서 화면이 안 보이더라고요. 이걸 여기 두고 화면을 보는 게 더. So I briefly introduced the FreeCAD. So as I mentioned, the FreeCAD is the open source CAD system. So highly customizable and scriptable and extensible. So you can modify this software. And FreeCAD supports the parametric 3D modeler, so it makes extremely to design real-life objects like notebook and in project and so on. And FreeCAD allows you to easily modify design. And then FreeCAD supports multi-platform, the Windows, Mac, Linux, Ubuntu, all of things. So this is mentioned, the first release 2002, last version is in this year. So FreeCAD provide feature-based parameter modeler and CSG modeler. CSG constructive solid geometry modeler. So CSG used some primitives and Boolean operations. You can and then make some final models. And parametric modeler means use the sketch and path, focal, revolve, sweep, and so on. And FreeCAD use the open cascade modeling kernel. It's also open source, and FreeCAD use the PySide for GUI, and built-in Python interpreter for macro and script, and all of things in FreeCAD. So FreeCAD also supported the lot of several file extensions, the itself file format and DXF, step IGS, and several mesh formats. And so this is some information for viewers. So you can access. Yeah, you can access to FreeCAD homepage when you have the home project. You can get the information about the FreeCAD. So major thing is maybe you access the API section. They explain the supported API document. So sketch modules, and this is some class, explain the class and some functions. And then you can use the tutorial in this page. The text tutorial. And then they provide YouTube video tutorials also supported. So you can see the video and then you
How many videos?
I don't know. I didn't check the video. In this channel, anyone can upload this. And then you can tutor by text.
Is there any video tutorial for programming?
I can find for programming. Just use the FreeCAD to model it. Yeah. And I briefly explain the FreeCAD GUI. In this section is the 3D view. So it shows the content of your document and macro file and the models. And this is a 3D view. It shows the hierarchy and construction history of your result. And yeah, this is a property for the colors and text, size of text, some information. And this is the report view. This is for the script, the error report, or show some information about your script. And then this section is you can type the comment, and then you can make the models in this functions. And this is the selection of the workbench. The FreeCAD provides a lot of workbench. The sketcher, part design part, ship, robot, anything. But in this template, maybe you use the sketcher and part design, maybe 3. So this, if you want to use the macro, you can access these buttons, the record the macro and run the macro and edit the macro. I have some demonstration. 원격 관련해서 줄까요? 네, 아니죠. This is the FreeCAD UI. So you can record the macro, use this button, and then type the name, and then click the record. And now, so make new document. And this Python console show the some comment about your action. So you can check the comment of your action in this console part. And then make a sketch, the simple sketch. Edit new sketch in XY plan. Make a circle. And finish it lacquer. And then you can use the macro, and then you get the same result like this. So when you develop the translator, you can check the command of FreeCAD like this. Use macro. You can.
Is the Python console same as macro file?
Yeah. As another example, I have the this is the macro script for to make some like this shape, So use the function of the FreeCAD. I can make the GUI and some macro script file. So like this, this part is for GUI, and this part is for make solid model. So as you can see, the document, this comment is the same as this comment. So you can use a comment directly. So you choose the folder and then use the selected macro and execute like this. You can make the GUI and then make the model easily. You can. This is for macro. And next one is Python console. I also explained about the Python console. So I show some example how to use the Python console. Firstly, import the module if you want. I make the line so in 3D space. So import part UI and then make a new tab. Like this, you can use easily the command and check the which function supported in this class. So active document. The line is the part line. The start point is the 0, 0, 0. Add the line in document, the comment document, add object, which object is part feature. This is the name of the object, so my line, and then so as you can see, make the line use the comment console. At the same, you can use the copy and paste. Like this. So you can use the Python console like this. And I introduced briefly the previous work, 2 years ago. So at that time, I made a translator between the CATIA to FreeCAD. At that time, I just used the text to text, then use the API or some other functions, just text. And this is some with the execution file. So I read the CATIA script file and then some working, and then we got the FreeCAD macro script file. So this is scenario. So firstly, in company A used the CATIA and company B used the FreeCAD. So they are work together, but they use the different software, so they didn't modify the change of design. So at that time, we developed the translator, and then the company B can modify the model made by CATIA. So CATIA script file and then translator, and company B can make the FreeCAD model, and then finally they can modify the model from CATIA. So this is workflow, the same story. At that time, my term project supported two features, CAD and FreeCAD, and two sketch features, line and circle. So the result of my term project, firstly I used the primitives, the cube and cylinder, and then after checking my software, and then I tested the K1 model. We can transfer to CATIA, from CATIA to FreeCAD. Yeah, that's all.
How can you read the sequence of actions in CATIA or in any commercial software, the macro file?
In sequence, just read the text. Use the basic function of the Python.
In commercial software, in CATIA?
No, the CATIA macro script file just text.
Just text.
Yeah, so we can read the text file.
Right. Kind of reverse engineering.
Yeah. Anything else? Thank you.
You introduced about FreeCAD API. Should we use the API or just make a file?
Yeah, you can use. And the command is check click a button and the console window, and use that command. Just use the same.
The macro file for FreeCAD is Python script, right?
Yeah.
And the macro file for CATIA was a text file.
Yeah. But the text and Python macro script file very similar.
Right.
Okay, I will introduce you about the microparametrics approach, and the result of this project is Transcript. And we are developing this Transcript now. Since Youngki has explained many things, go very quick. This is usual CAD modeling approach. I assume you have already experience of modeling using some commercial software. And by making this shape, you can export it as a just explicit model without this kind of history. But as you heard, we need this kind of information, operation feature, and this kind of procedure. We need that. So there are two modeling approaches. One is explicit modeling, and the other is procedure modeling. So if you have explicit model, for example, in the left-hand side, if you see the chessboard, then you don't know how this game went like this. It can be many possibilities to reach this state. But if you see the right-hand side, then there is a history, which thing goes where, something like that. So if you have this kind of procedure, and it will be easy to understand how it goes. And in terms of 3D model, if you have explicit model, then it is very difficult to edit the model. So what we want to achieve is, this is as-is process using just explicit model, for example, step format. If you export, model it with a commercial software and you export step file, and then the other software gets the exported file, but they cannot edit it. But if we can export the feature and parametric information and from CAD A, and in CAD B you get that information and you can edit the model. So the final goal of macroparametrics approach is like this: feature-based or history-based exchange of parametric CAD models. So as I mentioned, for the exchange of the feature and parametric information, we are using macro file for that information. So MPA, I would say MPA is a methodology of exchange of CAD model data between CAD systems using macro file. So this macro file contains the modeling operation history from the scratch to the end. So we define common set of feature comments provided by commercial CAD systems, for example, CATIA and UG, NX, and SolidWorks. So we define this neutral common set, and then by using this neutral macro file, we can make a translator by mapping the macro file of CAD alpha to neutral file. This processor is doing that kind of mapping, and then we can easily exchange the model. So this is an overview of a macroparametrics approach. So similar picture you saw. We have a transcad here, which you will use, and it provides also some kind of API. This transcad provides some kind of API, and then you get the macro file of alpha from the CAD system alpha by preprocessor, and then you can export it as a CAD system beta, and after exporting it, you can modify this model because you have a history and feature information. And this transcad also supports, it has its own format, which is a neutral, we call it neutral macro in XML format. So you can use this macro file as a just text file, or you can use this API, whichever you want, to make translators. So I will just skip it. What is macro and what is API, since you already have understanding. So we have this transcad, and it has several modules, and we are using ACs and hooks for the geometric modeling, corner, and visualization, 3D visualization. And it also has an interface, but it's not similar with the commercial system. You can, when you use commercial system, you can use keyboard and mouse. You can have some manipulation, but it has only script interface. And as I said, it has a macro file. And for developing translators, you can make use of automation API, which is provided by transcad itself. So yeah, recently we developed transcad web modules. So if you go this homepage, and you can check the translation and visualization on the web. And this is a development environment of transcad itself. So we are using C++ as a language, and So AC is for the geometry modeling corner, and hoops for the visualization module. So, and this is Transcript. And when you develop FreeCAD translator in this TOM project, then it can be integrated into Transcript as a GLL type or another type. So we have this kind of team. We have currently 3, 4, 5 teams. And this is current project. We have Katya and Yuji and Abiba Marin and BIR CAD. And the red colored one is now, it's stopped. And we have some test cases, K models, KAIST models, and C models, which is provided by some project which is called CHAPS, CHAPS. And we select A models recently for the testing translation of assembly models. So, in summary, object of this TOM project is to develop this pre and post processor of FreeCAD, between FreeCAD and Transcript. The target model is, as Youngki already said, K1 model. It has maybe 2 or 3 features. So each team should develop this FreeCAD pre-processor and also post-processor. So while you developing these kind of processors, you can make macro file of FreeCAD or macro file of Transcript. Or either you can use API functions of these 2 CAD systems. So you just set a target whether you use macro file, text file, or API functions. Either way, you can create or generate the model. So it's up to you. It's a kind of a composition of the preprocessor. All you need to do is parsing something, for example, macro file, and you just map the information, reference information, and sketch information, and feature information between FreeCAD and Transcript. Okay? The post-processor is the other way around. The arrow goes the reverse way. So it's, all you need to do is mapping in a translator. Write the code in C++, whatever. So I've made Katya pre and post processors. So I will show you how it goes. You can use any programming language. This is a Katya script file. If you open it, it is just text file, which is recorded by Katya. So it contains the feature and procedure. So if I open it, then you'll see there's information. And from Katya preprocessor, it is already integrated in the Transcript. This is a Transcript. And if I import by Katya preprocessor, then it will generate the exact same K1 model in the Transcript. And then the reverse way is very simple. If I export it to Katya K11, and then I save it, K11 will be generated. And if you open it, and then the result will be the same. So it's what you have to do for the TOM project of this semester. So the different thing is I used Katya and you will use that. Okay. So you will need some time to study macro file of FreeCAD or API functions of FreeCAD, and also Transcad macro file and API function. So we'll need time to study those things first, and I can help you with the Transcript, and Youngki will help you with the FreeCAD. But yeah, I will circulate some useful information and documents for you to study, and maybe sometime we can have a time to teach you how to use API with Transcript, something like that. So that's all for me.
Can you show us a neutral macrofile?
Neutral macrofile.
What it looks
Okay.
like?
So we have a K1 model here, Transcript, and I can just save it. And then here is a XML file, and which contains the exact same information. And I can, of course, open this file.
So by neutral, you mean the file format for Transcript, the default file format?
Yeah, it's default file format of Transcript itself.
Right.
So you can use just two text files in Python code in FreeCAD and XML file of Transcript. You can just map it. But I will explain it later, but the important thing is selection. So we will need some time to understand the selection procedure. Because if we want to make a sketch, we need to have a select a plane or face, right? So if I click this face in the FreeCAD, then I should select the exact same face in the Transcript, right? This kind of procedure you really need to understand, and you will need some time to understand. So, yeah. Any more questions?
Can you show us the APIs of Transcript?
APIs?
The functions of Transcript? C++?
Yeah, I can show you, but not right now. So I will teach you how to use it. It's not that difficult, so we will use it. And also, the last thing I want to tell you is if Transcript supports its own script interface. So, yeah. So it can be used as another macro file of Transcript. It has only its own syntax. So its own syntax to create this model. So you can either use this one or XML file that I showed you. So this is that's all.
Okay, because of the time, we can delay the discussion session to the next Monday. We can start from discussion, right? Next Monday. Also, Soonjo will provide another short presentation about API of Transcript.
Okay.
And also, I heard that there is a mission